Appendix B.3, Part B. Second half of the section is going to review a bunch of different types of equations that you have learned to solve in the past. Make sure when you're going through the homework you're reading the directions, because it will give you specific methods that you need to get practice on as far as reviewing your equation solving techniques. Looking at letter A here, we're solving by factoring. X squared plus 2x minus 24. Factoring a trinomial, remember trinomials always factor into two binomials. So we're looking for numbers that multiply to be negative 24 and add up to be positive 2. Those are positive 6 and negative 4. Once we have an equation in factored form set equal to 0, remember we finish solving then by taking each factor, setting them equal to 0, and solving. So x plus 6 equals 0, x minus 4 equals 0, and our two solutions then are negative 6 and positive 4. Letter B, x to the fourth minus 3x squared plus 2 equals 0. Once again, we're going to solve this the same way we did in letter A, only now instead of our factors being linear factors, x plus 6 and x minus 4, we're going to have quadratic factors here so that when we multiply it, we get back to our x to the fourth. So we have x squared and x squared instead of x and x. We're looking for numbers that multiply to be 2 and add to be negative 3. That's negative 2 and negative 1. And we're going to set each of those factors equal to 0 and continue solving. First one, we get x squared equals 2. Take the square root. X is plus or minus root 2. Second factor, x squared minus 1 equals 0. X is plus or minus 1. There are our four solutions. Letter C, third type of factoring. Anytime you see four terms like this, you should have light flashes going off saying, oh, I need to factor this by grouping. That is, anytime you have four terms, you need to think about factoring by grouping. When we factor by grouping, just as the name says, we're going to group terms together. So when I go to rewrite this, I'm going to group the first two terms together, 2x cubed minus 6x squared. I'm going to put grouping symbols around them. I'm going to group the second two together. Now, here's a common mistake right here. When you add that grouping symbol, remember that negative has to get distributed back to both terms to get back to our original equation. So that's going to become a minus 18. If I was to distribute this negative back through, I would get minus 6x, which is what we want, and plus 18, which is what we want over here in our original equation. Once you group them, take the greatest common factor out of each group. First group, we can pull out a 2x squared, which leaves us with x minus 3. Second group, we can take out a 6, which leaves us with x minus 3. Now, in common, both of these groups have an x minus 3. So I'm going to pull that out front. When I take an x minus 3 out of this first group, I'm left with 2x squared. When I take an x minus 3 out of the second group, I'm left with a minus 6. Now we have it set up like the first two. It's in factored form, set equal to 0. So we set each of the factors equal to 0 to continue solving. We get x equals 3. And x equals plus or minus root 3. There's our three solutions. Solve the equation with the quadratic formula. So now we're changing our method that we are going to use to solve. Quadratic formula, remember, is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. To use the quadratic formula, remember we need everything on one side. A, B, and C then are in order. A is the lead coefficient on the squared term, B is the lead coefficient on the linear term, and C is our constant. Identify A, B, and C. In this case, A is going to be 1, B is going to be -5, C is going to be 3. Once we have those identified, go ahead and plug directly into the formula. X equals the opposite of B plus or minus the square root of B squared, which is 25 minus 4 times A times C all over 2A. 25 minus 12 is 13. We cannot break this down any further, so there are our two solutions, 5 plus or minus root 13 all over 2. Solve each equation by completing the square. Completing the square has certain steps that you must follow. Let's review those. First thing we must do is move the constant over to the other side of the equation. So let's go ahead and do that. That's going to leave me with x squared plus 6x, and I'm going to subtract the 2 over to the other side, so now it's equal to -2. You must move that constant as your first step. Step 2, your lead coefficient must be 1. If it's not 1, then you need to factor whatever that lead coefficient is out. So if that was a 2x squared, I would have to factor a 2 out. In this case, it is 1, so I can skip over that step for this time. Third step then is we actually go through the process of completing the square. So you have to do those 2 preliminary steps before you can even worry about completing the square. Now to complete the square, you always take half of the middle term. So in this case, I'm going to take half of 6, which is 3. That's going to be an important number later on, so we don't want to forget that. After I take half the middle term, next step is to square that value. So in this case, I'm going to take that 3, I'm going to square it, and we get 9. Completing the square, we have made now our perfect square. That is what we are going to add to both sides of the equation. Once we do that, completing the square makes a perfect square trinomial, which we have now created on the left-hand side of the equation, that always is going to factor to whatever half that middle term was. In this case, the half the middle term was +3. So this is going to factor as x plus 3, the quantity squared. So there should be no thought process into looking at that trinomial and being, well, I'm not really sure how that factors, because every single time it's going to factor to whatever half of the middle term was. So x plus 3 squared equals -2 plus 9 is 7. From here, continue solving for x. Take the square root of both sides. Finish solving for x, subtract the 3 over. And there are our 2 solutions found by completing the square. Solving equations involving radicals. To solve an equation involving radicals, basically what you are going to do every time is isolate the radical. So in this case, I want to get the square root of 2x plus 7 all by itself. I'm going to do that by adding the x over. Once you isolate the radicals, second step, square both sides. So when I go to square both sides, here is the key. So on the right side, I'm going to get a FOIL situation. When we square a square root, we just get what's underneath. But over here, I need to FOIL this out now. We get x squared plus 4x plus 4. We now have a quadratic equation. How do we solve a quadratic equation? Every time we get everything on one side, set equal to 0, factor, or use the quadratic formula. Subtract the 2x over. Subtract the 7 over. Quickly look at this and see if you can factor it. If not, use the quadratic formula. This is factorable. X plus 3 and x minus 1. Set each of those factors equal to 0, and we get x to be negative 3 and 1. Just like earlier in the appendix sections when we had to check for extraneous roots when we had a variable in the denominator, we also have to check for extraneous roots when we have a variable underneath a radical. So I need to check each of these solutions. If I put negative 3 in here, we get negative 6 plus 7 is 1. Square root of 1 is 1. 1 minus a negative 3 becomes 1 plus 3, which is 4. 4 does not equal 2, so that solution is extraneous. Try the 1. Put 1 in. 2 plus 7 is 9. Square root of 9 is 3. 3 minus 1 does equal 2, so our only solution here is x equals 1. Okay, when we have multiple radicals in an equation, we start the same way. We want to isolate one of them. It does not matter which one. In this case, so I'm dealing with positive values. I'm going to add this square root to the other side. So I get the square root of 2x plus 6 equals the square root of x plus 4 plus 1. Once it's isolated, just like we did in part A, I'm going to square both sides of the equation. Not each individual thing, but the entire sides. On the left, that's easy to do. Squaring a square root just gives us what's underneath. On the right, a little more difficult now because we have to FOIL out an expression containing a large radical. Well, we still should be able to handle that. So we're going to have the square root of x plus 4 plus 1 times the square root of x plus 4 plus 1. FOIL that out. First, we're just going to get x plus 4. Outer, we have a square root of x plus 4. Inner, we have another square root of x plus 4, which means we have 2 of the square roots of x plus 4. And last, 1 times 1 is just 1. From here, we still have a variable inside a square root, so we still need to isolate that radical. So I'm going to move everything else away from this. So I'm going to subtract the x over. I have 4 plus 1, which is 5. I'm going to subtract the 5 over. And we're left with that. From here, we have the radical isolated again. At this point, if I can divide by 2 and not create fractions, go ahead and divide by it. If you're going to create fractions, you might as well just leave it over on the other side. So I'm going to leave it where it's at because I don't want to get fractions. Left side now becomes a FOIL situation, x squared plus 2x plus 1. The right side now, when you square this, make sure you square both parts. 2 squared is 4. Squaring the square root just undoes it. And now, once again, we have a quadratic equation. We need to get everything on one side, factor, or the quadratic formula. Subtract the 4x over. Subtract 16 over. Once again, look to see if this factors. Again, we have a factorable equation. X minus 5 times x plus 3 equals 0. Two solutions are 5 and negative 3. Once again, we need to check these to make sure that we did not create an extraneous solution by squaring things. Plug the 5 in. If I put 5 in, we get 10 plus 6, which is 16. Square root of 16 is 4. Put 5 in here. 5 plus 4 is 9. Square root of 9 is 3. 4 minus 3 does equal 1. That solution's fine. Put in negative 3. We get negative 6 plus 6, which is 0. So we have 0 minus. Put negative 3 in here. Negative 3 plus 4 is 1. Does 0 minus 1 equal 1? No, it equals negative 1. So once again, that's extraneous. Our only solution is x equals 5. Number 10 here. Part A, x plus 1 to the 2/3 power equals 4. Remember that anytime we have a fractional exponent, that we can write that as a radical as well. For instance, x to the 1/2 power is the same as the square root of x. The cubed root of x is the same as x to the 1/3 power. So we can go back and forth between radical form and exponential form at any time. In this case, if I want to undo raising something to the 2/3 power, let's raise it to the 3/2 power. Exponent raised to an exponent, we multiply exponents. Well, what's 2/3 times 3/2? Well, the 3's cancel, the 2's cancel. We're just left with x plus 1 to the 1st power. Over here, plug that into your calculator. 4 raised to the 3/2 power is 8. Subtract the 1, and we're done. X is equal to 7. Letter B, fractions in an equation. Remember, we want to get rid of those right away. So I'm going to multiply by the least common denominator, which is x times x minus 2. When we do that, first fraction, I still need to multiply by the x minus 2. Second one by just the x. Third one by both x and x minus 2. Begin simplifying. We have 2x minus 4 equals 3x minus x squared plus 2x. Again, we have a quadratic equation. Anytime you see a quadratic equation, get everything on one side, set equal to 0, factor or quadratic formula. I'm going to move everything to the left. So I'm going to add the x squared over. 3x plus 2x is 5x. Subtract that over. Factor or use the quadratic formula. This is factorable. X minus 4 times x plus 1. Set each factor equal to 0. Two solutions are 4 and negative 1. If I check those, neither one of them makes the denominator 0, so both are good solutions. Last one, absolute value equations. Remember, in an absolute value equation, something as basic as this, absolute value of x equals 4, how many solutions does that equation have? Has 2 of them. When x is equal to 4, or x could be equal to negative 4. And that's how you're going to solve all absolute value equations. You're going to isolate the absolute value, so it's just like what we did with radicals. In this case, it already is, and then we're going to always break it into 2 cases. Remember, with the radical, we isolated the radical, squared both sides. Absolute value, you're going to isolate the radical and break it up into 2 cases. When x squared minus 3x equals negative 4x plus 6, and when x squared minus 3x equals the opposite of negative 4x plus 6. Solve each of those 2 cases then on their own. Quadratics, get everything on one side. This is factorable, x plus 3 and x minus 2. So we get 2 solutions there, negative 3 and 2. Do the same thing with the second one. This becomes positive 4x, so when I subtract that over, I get x squared minus 7x. Negative 6 I need to add over, becomes a plus 6. Finish solving. X minus 6, x minus 1, and there's our final 2 solutions.